Good morning and welcome to today's alumni sharing session. Thank you for joining us for this panel discussion. Today, we will be mainly talking about the journey from university into the engineering industry, especially around analog IC design and the wider semiconductor ecosystem. So the aim today is just not to give a perfect answer to you guys. It is more of an honest sharing session. So we really want to talk about what the working environment is really like, what surprised us when we first started, and what advice we would give to students who are preparing for internships, interviews, or their first jobs. And before I introduce myself properly, I would like to invite the other speakers to introduce themselves first. Maybe just share your name, your background, your current role, and briefly what kind of work that you are currently doing now. So maybe Agil, we can start with you first.
Thank you, Nigel. It's nice to have 290 of you on board here. It's a bit overwhelming. But hi, my name is Agil. I am an electrical and computer systems engineering graduate from Monash University. Currently, I'm an embedded software engineer at Motorola Solutions. If you do not know, it's the first company that created the handheld mobile phone in the world. And I'm also an ASEM alumnus from the cohort of September 2025 for the embedded systems pathway. And yeah, that's about my intro.
All right. So Jazman, over to you.
Thanks, Nigel. Hi, everyone. I'm Jazman, and I was a physics graduate from UM, and I was also the ASEM NCEP Digital IC Design July last year cohort. And I've been fortunate enough to be employed under SkyeChip for almost a year now under custom layout and physical design. So throughout my journey, I've been through multiple projects, tape out, and also done full flow work. I'm very excited to share what I've learned, what I've done, and also to answer all of your questions. Thank you.
All right, Fazlyana, maybe you can go ahead and introduce yourself.
Hi everyone, I'm Fazlyana, currently working as an junior IT application. My role scope mainly involves handling operational technology issues in the production floor sites. For example, the MES, manufacturing execution system, to monitor our production floors, production display hardwares, and also the back end of it, data transferring from system to the machines. So I'm Agil's classmate, last year's September cohort. And so today I'm as a friend to share my earlier career insights for all of you guys. Nice to meet you.
All right. So thank you for the brief introduction. I will briefly introduce myself as well. So hi everyone. My name is Nigel and I studied electrical and computer systems engineering at Monash. Exactly the same with Agil, right? And we were uni mates. And I have completed the National Semiconductor Excellence Program back in February 2025. And since then, I have been working in chip implementation and physical design, mainly on the wireless and IoT chips. And I'm also still quite early in my career, so I'll be sharing from the perspective of someone who recently transitioned from university into the semiconductor industry. So I'll be moderating today's session, but I will also be adding some of my own experience where relevant. So all right, with the introductions done, let us kickstart this panel session with our first question. So when we are still students, right, we often imagine professional engineering work to work in a certain way. Some of us expect it to be very structured, and some of us think that the job is mainly about technical knowledge, but once we enter the industry, the reality can be quite different. So my first question to you guys is this. What was your expectation of working in a professional engineering environment, and what was the reality once you actually started? So maybe Jazman, maybe you can go first.
Sure, Nigel. Thanks. So basically, when you join a professional company, you thought that, okay, they give you a manual, they give you training. So whenever you enter a project or got a problem, you just follow step A to Z and they can solve it. But more often than not, that was not the case. So usually you have to experiment around, tinker, and find out your own solution. Or maybe some other solution, someone else before you have found out. And then you got to ask them how to solve that certain problem. Of course, the training covers the fundamentals and all, but more often than not, in the real life scenario, there's always edge cases, there's always special cases that you have to take note and understand that, okay, this is a special case. Maybe I can try to solve this, maybe I can bring it up to the seniors, or maybe I can ask other people. So it's basically the methodologies come from testing, experience, asking around, word of mouth, or just finding out. Yeah.
Right. Yeah, thanks, Jazman. I think that point is very real. So as
Mhm.
students, we are often expect that every task will have a manual, right? Or maybe a fixed rule or a standard way of doing things. But in the real workplace, even though there are guides and rules, a lot of the actual methodology comes from the testing and experience, and of course, asking around and learning from people who have done it before. So maybe Agil, I will bring you in next. So at least from the embedded software side, your work may not be analog IC design directly, but it is still very close to hardware and system level thinking. So before you started working, do you expect the job to be mostly coding? And what do you realize after entering the industry?
Okay, I think the biggest breach between expectation versus reality, because coming from university, I thought embedded systems is got probably about like registers, manipulate the bits, and bare metal programming, and basically writing firmware from scratch. But the reality was it was much broader than what I thought. I quickly realized that writing code is only one part of the job as an embedded software engineer. You also need to understand how the entire system fits together. Just going to throw in some jargon here. Some of you are familiar with it. Something like bootloaders, firmware, partitions, file systems, caches, operating systems, and basically how all these software components interact with hardware at every layer. And one more thing that surprised me most is that the industry doesn't just pay you to write code, they pay you to understand systems and solve problems. So the better you understand the bigger picture, the more valuable you become. Yeah.
All right, Agil. Yeah, I really like the point about understanding the system. It is definitely not just about writing code or completing one small task, right? And in real engineering work, oftentimes you will need to understand how things fit together. So maybe Fazlyana, I'll rope you in here. At least from your IT application and operation side, your perspective is slightly different. So what was your expectation before joining, and what was the actual work like once you started?
My expectation kind of same with Jazman and also Agil. We had the same like I expected in the other industry we had a structured user requirement, a structured documentation. Okay. We solve a problem, there's a problem, then we solve it. There's a documentation on it. That's my expectation. But in reality, it's different. It's really different that you are not just building like in anything in IT or either you are in IC design or any other industries. You are not just building, but it's the way you understand the problem, the way you identify the root cause. Like Agil said, I want to highlight the point that you need to think in a bigger picture, and that's what you need to do. That's the reality now in your early careers lah, for me.
See. Okay. Yeah, thank you for your point. I think that is a very practical perspective. So, I mean, just to add on to some of your points, for me, my expectation was that at least in analog IC design, it would be mainly about the circuit idea itself. So you design it, you simulate it, and if the result looks good, then the difficult part is mostly done, right? But once I started working closer to implementation, I realized that the reality is oftentimes much more messier. So a design still has come with physical chip, and that means that the layout and the connections have to line up properly. And sometimes an issue looks like just a tool error, but the real question is whether that physical layout actually matches what the designer intended. So for me, the biggest reality check was that analog work is not only about that clever circuit design, it also needs a lot of patience and careful checking because that small physical details can really affect whether the block is really ready or not. And maybe I just ask a follow-up question on that. Once you entered the working environment, what surprised you the most during your first year? So maybe Jazman, you can start this first.
Sure. When I was in training ASEM, of course, I was exposed to multiple like industry tools. But then when I joined in SkyeChip, I was mainly working as a custom layout. So the tools we use are Cadence Virtuoso and Synopsys Custom Compiler. I'm not sure if any of you are familiar with it, but basically I do design on those tools. And then I thought, okay, those tools are just made for design. So I learned about the tool, learned about the design, and I can do my design. But I found out that it's much more in depth than that. Usually these tools, because they are industry standard, they have extra capabilities such as scripting, AI implementation, coding, and such, so and so so. So my advice is, whenever you have the privilege of joining a company, and being exposed to this kind of tool. Mind you, these tools, their licenses are very expensive. So usually it's not common for universities even, to have this kind of tool. So whenever you get exposed to this kind of tools, I implore you to play around, experiment, tinker, not just for your project, but maybe during your free time or during a downtime, you explore what extra features are there, what's so special about it, what can help you optimize your work, make your work faster. And even after multiple projects, I keep finding out, and I'm sure even for my seniors, they find out new things about the tools every time.
All right. Thank you for your perspective, Jazman. And maybe Agil, what about you? What surprised you most when you started working?
I think the biggest surprise wasn't really technical because I joined ASEM National Semiconductor Program before getting into a career that led to the same pathway, fortunately. The biggest surprise was how much companies are actually willing to invest in helping new engineers succeed. Because when you're a student, you think your value comes from how much you already know. But in the industry, at least for me, people understand you're new. And what matters more is how quickly you learn and assimilate information. I was surprised by the amount of documentation, knowledge transfer sessions, mentorship, and onboarding support available from Motorola. Of course, it's a multinational company. And another surprise was daily stand-ups. I generally thought like stand-up was just a name for the meeting. But then I found out in my company, we actually have to stand up literally to give our daily updates. So that was like a shocker. Yeah.
Okay, I see. All right. So how about you, Fazlyana? What was your biggest surprise when you started your role?
My biggest surprise. One of my biggest surprise is how steep our learning curve I am in the first year. In the first year, you'll be exposed to varieties of new system, right? For me, as a woman in this field, I would be exposed to all of the new system, new tools loaded with new technical jargons, technical terms that you weren't covered in your university's days. My university days are more on documentation, but in this role, I'm into more into technical things, work with process engineers, work with like manufacturing engineers. So for sure, you will know a lot of technical terms. Well, for me, it's quite overwhelming. But over time, when you manage to connect the dots, right, it won't be surprised and you can understand everything better. Yeah, I think it's normal to feel lost at the beginning. It's quite surprised, but it's normal. So just keep learning step by step.
Yeah, definitely. I would definitely echo your point, especially on Agil's point, right? So
Yeah.
yeah, maybe we can just move from expectations into the early career stage itself, right? So I think one thing every young engineer eventually realizes is that the first few years are not only about learning tools or technical knowledge, it is also about learning how to communicate properly, handle responsibilities, and work with people who are way more experienced than you. So my next question is this. What was the biggest challenge you faced when transitioning from university into industry? So maybe Jasmine, I'll start with you. So from your experience, what was one of the biggest challenges when you moved
Sure.
from university into industry?
Sure. So basically, for my case, I'm actually a physics student. I'm not really an EE student, but I do learn a bit about transistors, electronics, at least the basic stuff. So when I transitioned to from university to industry, of course, the university teaches us about the theory, the fundamentals, and so on. But it could never prepare for what is waiting for you when you are starting to do actual work. So they don't really teach you how to use the tools. They don't really teach you like, okay, what kind of problems or what kind of design you'll be working on. So these kind of things you get exposed during your career. So I'm not trying to downplay the fundamentals are important, but if I would put it simply, I say 90%, 95% of the things you learn will be on the job, as cliche as it sounds. But that is to say fundamentals are very important. You're going to use it often. Yes.
Yeah, I definitely agree with your point, and I think that is very true. So university often just gives us a theory, but the actual application and the way of explaining problems to people are things we usually only learn after only entering the workplace. So maybe Faziana, from your side, what was challenging when you first started working in a professional environment?
For me, it's the feeling. Yeah, yeah, you understand, right? When you work with experienced engineers, technicians, it can feel quite some kind of intimidating. And yeah, at first, I know I'm afraid. You will be afraid to speak up, to ask something, to ask questions. You think that, oh, is this a dumb question? Is this not? Yeah, it's the feeling for me, because it's quite overwhelming also, because there's a lot of things you don't know. So you want to keep asking, keep asking, keep asking. And also for like in discussion between your seniors, you feel intimidated to interject what they are discussing now. Yeah. Then, believe me or not, some of the superiors really like the perspective of us younger generations, of us who are into this early career, because bringing up issues in discussion make it more impactful. As you know, in this discussion make it like more impactful and also effectively in work. Yeah,
I see.
the challenge for me is the feeling.
I see. Yeah, thank you for your point. I think many fresh graduates can relate to the feeling of being intimidated when working with experienced engineers and technicians. So maybe Agil, from your perspective, what was the biggest challenge for you when you moved into industry?
Thank you for the interesting question, Nigel. To be honest, I don't find industry harder than university. University was much more stressful for me.
I agree with that.
And ASEM prepared me really well because I eventually landed a role, as I said, directly related to what I studied. What I learned though is that maybe only 10% of your university knowledge gets applied directly, and the other 90% is learning how to apply what you know in unfamiliar situations. For example, I once had to investigate, like I'm working with walkie-talkies and radios, right? So we have this proprietary software to analyze the packets and whatnot, but it couldn't really serve its purpose in when the radio was in boot mode. Nobody told me to use like packet analysis, which I learned from university, but I remembered the concepts and used Wireshark, for example, to analyze the communication packets and found a lot of useful clues. So you think for now you only apply 10%, but the other 90% stays passive over there, and it will help you one way or another if you choose to make your workflow more efficient. And I think that's where the education becomes valuable, not only memorizing facts, but learning how to think.
Yeah. Yeah, thank you very much for your point, Agil. And I definitely want to reiterate your point, right? So I definitely agree with you. At least for me, I would not say that there was one big shock when transitioning from university to my career, because I believe that the ASEM program, and I believe every one of you will agree with me, prepared me quite well for the kind of work that I'll be doing. So it gives me a really realistic idea of the flow, the tools, and also the way engineers check and debug issues. So I would say the bigger adjustment is more towards the seriousness of actually doing it on the real project. So let's say in training, if something goes wrong, it is mainly for learning, right? But in actual chip work, I would say every check matters because the result can actually affect the next person in the flow or even the readiness of the block itself. So I would say there's not really too much of a challenge for me as well. So the bigger adjustment was just actually knowing that the checks I was doing could really affect the next stage of a real chip design project itself. So, I mean, and moving on would be my next question, right? And my next question would be about mistakes and setbacks, because everyone will face them in their early careers. So when you make mistakes or face setbacks early on, how do you guys usually handle them? So maybe Jazman, you can start this off.
Mistakes. Yeah, I've made a lot of them. Yeah.
Yeah.
Basically, in the reality of joining a work, especially something new, you will make mistakes. You will have to redo your work. And you will have to stay longer or work extra, maybe at night or even weekends. And sometimes it's because you're slow, sometimes because you messed up. That's the reality. And that is to be expected. There will always be like this imposter syndrome where you feel like, am I suitable for this role? Am I good enough for this role? Did they hire the right person? But you gotta remember, you're a junior, you're a freshie, and you just got exposed to a new plethora of tools. And of course, there's this uncertainty where, like Nigel said, other people work is dependent on yours, and that actually added extra stress. But you got to remember, whenever something like this happens, you could always like troubleshoot and try to solve it yourself, but always bring it up to your superiors or seniors, because usually when you are in a real project, you are chasing deadlines. So everyone is dependent on each other. So whenever you are faced with this mistake, you try to solve it by yourself. But then if, let's say, it's major enough and it might impact the work or deadline, always bring it up to your superior and senior. They will understand. And they will appreciate you for doing so.
All right. Thank you for your point. How about Agil? What about your perspective? How do you handle it when you are stuck, or let's say when something does not go as expected?
I think one challenge for almost every fresh graduate is information overload when you enter like a new territory. Suddenly, everyone speaks in acronyms, internal terminology, and project-specific jargon. It feels like everybody understands what's happening except for you. So my biggest lesson, I would say, was learning how to ask better questions. Don't immediately ask, what's the solution, right? Instead, say, here's the problem, and here's what I've tried, and here's the approach I'm considering, and does this make sense? Like, verify as you go along. I noticed that people are much more willing to help when they see you've already made an effort. Resourcefulness is valuable. Independence is also valuable, but don't confuse independence with suffering in silence. That's the biggest lesson I would say I learned throughout my first year in employment.
I see. All right. Yeah, thanks everyone. I think the common thread here is that early career growth is not about pretending to know everything, right? It's also about being responsible, asking better questions, communicating early, and also improving after each task. So now that we have talked about mistakes and early career adjustments, right? Maybe you can go deeper into problem solving itself. So in engineering, whether we are talking about analog design, physical design, embedded software, or IT applications, one thing that keeps coming up is fundamentals. So the tools are useful. AI is, of course, useful as well. But at some point, we still need to understand what is actually happening. So my next question to you guys is this: how important are fundamentals and structured problem solving when you troubleshoot real engineering problems? So maybe Agil, I'll start with you. At least from the embedded software side, how important are fundamentals when, let's say, you are debugging or troubleshooting a problem?
One thing I've learned is that every complex problem becomes manageable once you break it down really small, like far enough. That's essentially engineering, making something sophisticated into a very simple algorithm. I use the same mindset to every problem that I encounter. You take something overwhelming and reduce it into smaller pieces until it becomes solvable. AI is fantastic. I use it every day and I'm encouraged to do so in my company, fortunately. But eventually you hit a bug where the AI suggestions stop working, and that's when your fundamentals take over. Your understanding of programming, memory, operating systems, communication protocols, and debugging become your safety net. Technology changes, but the fundamentals always stay relevant. Yes.
I see. All right. Thank you for your point, Agil. Yeah, and I think that is definitely very relevant today, especially with AI tools becoming so common, right? So maybe Jazman, I just want to bring it closer to analog IC design and custom layout. So why do you think the fundamentals are so important in your field?
Oh, basically, because I work with very small things. So the process I'm currently working on is it's called Samsung 4 nanometer. So if you know about transistors, there's source, drain, and gate. So the gate itself, the width of the gate is 4 nanometers. That's a lot of zeros behind. So whenever you're working with that stuff that small, you know that stuff like if transistor effects and semiconductor effects, like there's go a bit technical here, like substrate, well, oxide, and stuff. You got to consider that. So these kind of fundamentals, if you do not know about it, you'll be just basically following instructions. You will do what the training says, but you don't really know why you're doing it. And on top of that, you need to know how to troubleshoot. You need to know how to identify the problem and whether or not this problem is major enough to be solved now or to be put later. And then after you identify whether or not the problem is important, you try to document, troubleshoot, and experiment to solve it yourself. And then remember what you did. Only then, when you're stuck, you have to bring it up to your superiors. Because like I circle back, you are running out of time. Your time is of essence in the project. So don't be stuck on a problem too long. What I notice about my colleagues and juniors is sometimes they like to explore too much. They like to focus too much on one problem and delay their work tremendously. So you got to remember to know when to stop and when to ask other seniors. But remember to put in the work also.
Yeah, I definitely agree with your point, Jazman, and that is a very strong point. So if you do not understand the basics, it's usually very hard to even ask the right question, right? So maybe Fazlyana, from the operations and IT application side, how do fundamentals help when, let's say, you are troubleshooting a real system issue?
In the operational side, for me, yeah, fundamentals is it's important for you to back to basic. In IT or every field that you are into, we have errors. And from the errors itself, you need to know what is the back of it, what is the root cause of it. To know the root cause, you have to know what's the fundamentals of it. You have to know what's the basic of it. Because in every area, it looks the same. It may looks the same, but how you troubleshoot it, how you diagnose it, it's kind of like completely different. So yeah, fundamentals for me, it guides your thinking. It guides how you find the problem, how you find the cause. Yeah.
Thanks for your point. And I really think that connects well with all of the other rules here. So even when the field is different, right, the thinking is still similar. You still need to understand the basics, reproduce the problem, identify the trigger, and then test things properly. So I think at least for analog, the fundamentals are very hard to escape from. And the tools are useful, but they can only show what is happening. And let's say if your fundamentals are weak, right, you will still struggle to understand why it is happening. And so, at least for me, the problem solving starts with understanding the basics well enough, just to make sense of what the tool is telling you instead of reacting to the error. So, maybe just to make it a bit more practical, let's say when something breaks or does not behave as expected, how would you approach debugging and troubleshooting? Agil, maybe you can start this off.
Thank you, Nigel. I think I would offer my expertise based on more of the software POV. I think a lot of fresh graduates immediately resort to ChatGPT Codex or GitHub Copilot when something breaks. I actually try to investigate first. Like, for example, you need to be able to reproduce the bug. You're going to resort to checking the logs. You're going to go back to your VS Code debugger, step into functions, inspect variables, and understand what's actually happening. Because most of the times, the debugger can tell you more than AI ever could. And debugging isn't about being smart, it's about being systematic and collecting evidences before making any conclusions. And yes, use AI. I encourage AI. I'm not anti-AI, but don't spend tokens asking questions that your debugger can answer in 30 seconds. Please save some water and electricity for the data centers. Yes.
Yeah, I definitely agree with your point there, Agil. So, yeah, I like the point about reproducing the issue and then actually knowing the fundamentals before going into deep diving and solve the problem, right? So maybe Jazman, for layout or analog ICT related work, how do you usually break down the problem when you are troubleshooting?
Sure. So basically, first you identify this problem. Like I said, if during training you can spend all the time to solve that problem, but during a project, we'll identify whether this problem is important enough, or you can work on something else before you focus on this problem. After that, you try and go back to the fundamentals. You check whether, okay, am I forgetting something? Am I doing something careless? What did I forget as important step? And then after that, if you're still stuck, you document what you have done. You show that, okay, I've done this, I've done that, and only that you bring up to your superior and person in charge. And then after that, usually the problem gets solved. But let's say you found a very important problem. Actually, that could happen. And they could bring up to the other superiors, and basically sometimes the project had to be redesigned. Sometimes they have to bring up a new circuit. But overall, to simplify, troubleshoot first. Recognize whether the problem is important enough, or you can solve it later. Then troubleshoot yourself, document, only then bring it up. Usually after step 3, it will be solved.
I see. Yeah, thank you for your point, Jazman. How about you, Fazlyana? What's your take on this?
Mm, Mine is like quite similar with Agil's. He reproduced the problem.
Hmm.
Reproduce the problem to clearly understand what is happening, what triggers it. By that, I can identify what's the possible triggers and narrow down what's the root cause. The most important part is you have to know the root cause. If you don't know the root cause, it would be repeating issues happen day by day. Because for example, in my operational side, in my production floor, we always have this problem that it keeps repeating every week and every month. So for me, you should like by troubleshooting it, you could also know what's the root cause of it to end or to lessen the repeating issues. Yeah, for me, you need to like test it one by one. If you have a test system, you go test it one at a time, not multiple fixes. You have multiple fixes and you do it simultaneously. For me, it's not quite effective. For me, you need to test it one by one, stay calm, although you are in time pressure.
Yeah, I definitely agree with your point. So yeah, thanks everyone. I think that the takeaway here is that the fundamentals are not just your typical academic knowledge. They are what allow us to troubleshoot, ask better questions, and of course, avoid random guessing. As all you has mentioned, right? So maybe now we can bring the discussion closer to career decisions and advice for students. So many students here may be thinking about internships, first jobs, or even which technical path to choose. Some may be more interested in analog IC design, some may be more interested in embedded systems, and some may even go into operations or applications, right? So my next question is this. What should students focus on today if, let's say, they want to prepare themselves for their first job or career in engineering? Maybe Fazlyana, I'll start with you.
For me, one of the key things students should focus on is communication skills. I think with good communications, you can build trust within your teammates or within your colleagues, your co-workers, because you are dealing with not only the co-workers that in the same age, you are dealing with experience, different levels of experiences, different levels of age, or even the designation. You are totally different. But when you have a good communication skills, you make people to trust you. When people trust you, they are more willing to guide you because they're more willing to like share a little bit of more sharing knowledge sessions with you guys and support it with your growth in that company. And then yeah lah, for me in students nowadays, if you are in your university days, you should go active, go join events, go join programs, or even go liaise with your lecturers or any professors, but just go active, be active.
Yeah, I definitely agree with you that communication is a very practical point. So, I mean, in the workplace, it's not just about what you know, right? It's also about whether you can actually explain your problem and ask for help properly and build trust with the people you work with. So, I just want to rope you in, Jazman. At least from the analog IC design side, what advice would you usually give to students who want to enter this field?
So basically, if you on like electronics or EE, you already like very relevant to your path. But basically, if your university has access to industry tools like NC's, Cadence, Virtuoso, make use of it. But I know only a few university has it. I think UPM has it and some other universities. But if you don't know about it, basically, or even if you're not in EE, what I would employ is basically you try to you go to your university registrar, go to the EE section, and then try to find the professors or doctors or engineers that are related to these industry tools, and take the initiative to contact them and ask them whether or not that can you help them with anything. Can you like make a minor project, join something with them during your free time, and so on. So because this kind of practical exposure or work is very valuable in your CV. And then, other than that, you got to learn about the fundamentals about the role you want. Let's say if you want to go DV, you learn about the fundamentals of DV. You want to go to circuit design, you got to learn about circuit design. I mean, I can drop a name. I guess some of you guys are familiar with this, but there's one very famous guy. His name is Behzad Razavi, and he's very good at analog circuit design. And of course, I would like to recommend programs, upskilling programs such as like ASEM, GSAT, and NSEP. And I can prove that it's very useful. And I'm fortunate enough and thankful to say that I've gotten this job through ASEM, and ASEM has helped me tremendously.
Yeah, I definitely agree with your point, Jasmine. I think all of us here definitely have gotten a job due to ASAM, right? All of us can agree to that. And we are a testament to that, to the program itself. So yeah, that is very useful, Jasmine. So let's say if students do have access to industry tools, they should really use them, right? If not, they can still start with free tools, online lectures as you have brought up just now, side projects, and of course the Linux basics, and of course ASAM, right? And the important thing is to show that they have tried to explore the field seriously. So maybe Agil, from the embedded software side, what advice would you give students who are preparing for internships, interviews, or their first job?
I think networking matters more than most students think. Listen to me and listen to me good. Opportunities often come through people before they come through job portals. That's how I viewed the National Semiconductor Program. It's not only about upskilling, you're also meeting a pool of people, graduates who are eventually going to disperse into different countries, and then suddenly you have this network of people everywhere, right? So that's a really valuable asset that I gained by joining the National Semiconductor Program. So yeah, number one on that. And for the generic advice, I would say apply broadly. Don't put all your eggs into one basket. Sometimes you walk out thinking you nailed an interview and get rejected. Sometimes you think you perform terribly, you get an offer. So keep improving, and remember, you don't need 10 offers, you just need one.
Yeah, Agil, I definitely agree with your point. You really do only need one offer, right? So, I mean, at least for me, just to add on to some of your points, right? Because I think you guys have really good points. For students, I think the first thing is still the fundamentals. You really do need to know, you do not need to know every tool immediately, but you should understand the basic concepts well enough to build on them. And the second thing is learning how to articulate your thoughts properly. So in engineering, it is not enough to just understand something in your own head. You really need to learn how to explain the issues clearly, what you have tried so far, and what solution or next step that you are going to propose. So I would say focus on building strong fundamentals and then practice communicating your thought process clearly. So that combination usually helps a lot when you start working on a real engineering problem. So maybe you can just make it more practical for internships, interviews, and first jobs, right? So what can students actually do to stand out? So maybe Fazlyana, you can start this off first.
What can students do?
Yeah, so what can students do to stand out? So basically, essentially tips for internships, interviews, and first jobs.
Oh, for me to add on Agus' point just now, right? He said about, I want to highlight that he said about connections.
Oh,
Yeah, for me, make use of your connection, make use of your friends, make use of your classmate. I think students, although you are students, right, but you have lots of connections in your university, your lecturer, your professors, your classmates, maybe your classmates' father. We don't know. You have
yeah.
to like make use of your connections because your friends, they can be, and even your seniors. You know, my job now is a referral of my manager. It's a referral of my previous internship manager. Yeah. So it it is your connection. So make use of connections. It's a referral network. In finding jobs nowadays, it's really hard. And for me, I want to highlight that make use of it. Make use of your connections.
All
Yeah,
right.
that's the only advice. Yeah, fundamentals is quite important. If fundamentals is important, but second one, show willingness to learn. Although you are like so bad at this point, bad of this field, but it's okay. As long as you want to learn, as long as you have show your willingness to learn, that your superiors is quite happy to see it and they want to support it.
All right.
That's for me.
Okay. Thank you. So I just want to close this off, right? So maybe my closing question to this panel is this. If you could give one piece of advice to aspiring engineers, what would it be? So maybe Agil, you can start this off first.
Okay, this is gonna sound like a speech, but
Okay.
shameless plug. But let's go. Mm. Don't wait until you feel ready.
Yes.
Most engineers, including the ones you admire, they started without knowing what they were doing. Confidence is not something you gain before taking action. It's the result of taking action repeatedly. So start the project, apply for the internship, ask the question, submit the application, just start, right? The semiconductor industry doesn't need people who know everything. It needs people who are willing to learn anything. Okay. So that will be my advice to aspiring graduates.
All right. How about you, Jazman?
I
What
mean,
advice would you give?
it's a bit like Agil. I would say, study, experiment, tinker, play around. Show that you put in the work. Show that you've done your research. You don't apply to this role blindly. At least like you show that okay, actually on my side project or during my free time, I've done this and this and so. By putting that on your CV, I'm sure you already differentiate yourself from more than 90% of other applicants. Show that okay, before I applied to this role, actually I did so and so. I have a minor project or I learned about this, I can prove it during this interview, and so and so. So show that you put in the work and study, experiment, tinker around, and explore during your free time.
All right. How about you, Fazlyana? What's your last piece of advice that you would give?
Yeah, I share this as a friend lah, because
Mhm.
I'm just a few steps of you. We are just a few steps. And for me, please take every opportunity to learn. We are in our early careers. You don't even prevent any works. You need to volunteer or any discussion or any meetings. Just go volunteer. If your manager said you can do it, yes, you can, even though you don't know. You just said yes, you can. Because that's an opportunity for you to learn. And please take it. For sure, in our early days, right, guys, we have surely have struggles, ups and downs, and even you feel lost at the beginning. It's totally normal. For me, it's the part of the process. If we experience the struggles, which meaning that actually we are turning into a good engineers. The struggles are experience. So experience make us a good engineers. So don't be afraid to go struggles. Don't be afraid to volunteer. Just take the opportunity as long as you have.
Yeah, I definitely agree with your point. And I mean, my advice would be, of course, the short term and long term. Short term is apply for the ASEM program, right? Because all of us came from that program and we really benefited from it. So of course, short term wise, apply for the program. But long term wise, I would say you guys should learn how to debug properly. So in engineering, you will face many issues where the answer is not obvious. So instead of panicking or randomly trying fixes, right, learn how to break the problem down. Because at least based on my experience, a lot of people usually just jump straight into it and really do not have that fundamental, and they usually do not understand what is really happening. And more importantly, you need to be able to explain your thought process clearly. So I think that skill will not help you not only in analog IC design, but in almost any engineering role. So with that, we have come to the end of the panel session. So thank you to Agil, Jasmine, and Faziana for sharing your experiences and advice. And yeah, now we will move on to the Q&A session, if I'm not mistaken, right? So feel free to ask anything related to university preparations, internship, interviews, first jobs, IT applications, or just the semiconductor industry in general, right? So let me open the chat box and see if there are any interesting questions. So, hi Nigel, many of you came from different background. So, I'm going to take one question from Isaac. He's essentially saying many of us came from different backgrounds and ended up in different roles. Looking back, was there a particular moment where you realized which area of engineering suited you best? So, what do you guys think? So maybe Jasmine, would you like to go first?
Sure, but I mean, to be honest, it really depends on the availability per se. You could always try to apply for like let's say you were trained in ASEM digital IC design. You could always apply for RTL, DV, physical design, and so on and so on. But sometimes is you just need to be the right place and right time. Of course, if you are interested in a particular role, I implore you to focus on that role. Show that, like I circle back, show that you have put in the effort that will make you stand out. But more often than not, it might be quite common for you not to get the role you want. But usually, do not be too disappointed. Let's say you want to be a design verification engineer, but you got a role as RTL. I believe you should still accept that job because sometimes within the company you may even transition from one role to the other. So if you ask me to look back where aerial engineering suited me the best, actually that's a different story. I'm from physics, so it's the transition from engineering is a bit of a funny thing. But I realized that semiconductor is a booming industry, and I would join to ASEM because it's a very useful opportunity. So and then through that, I got to the physical design. I was interested in more on the hands-on practical design, so I entered as a physical and layout engineer. I'm very fortunate to get the role in SkyeChip.
I see. How about you, Fazlyana? What's your thought process behind it?
Um, this is the question where the moment you realize which suited you best, right?
Yeah,
I
that's
didn't
right.
realize anything.
Okay.
But how it's okay. For me, for my part, you need to show the willingness to learn.
Yeah.
So by you show your willingness to learn, it shows where you're passionate about. For me, right, in my company, my manager was the one who like, oh, I saw you interested in this one. I saw you're passionate on this one. Although I said different things like before this, I said I'm interested in IT servers. But then from my manager perspective, he said, oh, but then I saw you have potential in this part. You have potential in this part. You have potential in operation technology. It's how you show. It's how you show the willingness of you. There's there's no moment that I realized I didn't like I don't know which part of me I'm passionate about because
Okay.
I think it's on you. You need to show willingness, and people saw your potential. They will move you, or they will like move you to another position that you are potential about it.
I see. Okay. Yeah, that's a really good point because even before joining the ASEM program, I was quite clueless actually. How about you, Agil?
Yeah, clueless.
I think one term I would like to say is exposure therapy, which is grabbing all the opportunities you can to learn what you like. Like how do you find out what hobby do you like, what sports do you like, what subject do you like? It's because you tried all the subjects, all the sports, and you finally decided, okay, you got that moment of euphoria. Okay, this is the one that resonates with me, right? So I believe my degree gave me that the balance of hardware and software, and then it made me like gauge.
I think Agil kind of hang over there. It's okay. Yeah, he hang. It's all right. So, I think I'll just add on to Agil's point. Because we came from the same background, which is electrical and computer system engineering, and we did study at Monash together. But at least for me, from my viewpoint, I did not have any exposure to the semiconductor field, at all. If there were exposure, it was just minor. So what happened was I applied to the ASEM program. So that was where I started to understand the IC design flow better and became more interested in the work that is close to hardware. So when I started working in physical design, I realized I enjoyed the problem solving side of it. So I mean, sometimes the issue is not that obvious, so you would need to trace carefully and check the details. So I think that was when I realized that this area suited me very well since I like work that connects design areas into something physical that can eventually be manufactured and used in real devices. So that's my thought process. And yeah, and that was a moment where I realized that physical design is the area that really suited me. So maybe moving on to the next question. There are so many JDs out there, because I'm just reading off the question from Zach. there are many JDs, right, that ask for a long list of skills and tools. So, as fresh graduates, how much of that do you actually know before getting hired? So, maybe Fazlyana, would you like to start this off?
Job descriptions ask for long skills and tools, especially how much do I need to know? Did you actually know before getting hired?
I mean, at least for
Um,
me. I mean, at least for me, it's not everything. So,
yeah,
how
yeah,
about, yeah.
yeah, quite clueless also. But then for the rating, you need to know the fundamentals lah. For me, I think the rate 6/10 of your knowledge before getting hired. It's okay. You need to know what's the basic, what's the fundamentals of. If you are applying to an software engineering role, for sure you need to know codings, right? For sure you need to know Java or any low programming language. Yeah, you should know. We learn it in university, but then I think for me the rating is 6. It's okay for you to have no knowledge on this, no knowledge on that. It's okay. You have seniors for you to learn if you go into the company lah. If not, then you need to know the fundamentals of it.
I see. How about you, Jazman?
Basically, the question was about how much I know before, right? If
Yeah,
I
so
remember,
that
yeah.
because there are many JDs out there, right, that ask for a
Mhm.
long list of skills and tools. So as
Yeah.
fresh graduates, how much of that do you actually know before
So
getting into
I'll be honest,
yeah,
almost zero, because 99% of
yeah,
things I learn is on the job.
yeah.
But that's not to say that you cannot learn the fundamentals before. You can always use Google, AI, and Reddit to learn about stuff. YouTube books can help, but like I said, unless you get an exposure to, unless you have the access to the licenses or the industry, you won't learn much. But you have to brush up on your fundamentals so that when you start, when you get to the job or even during the interview, you can start very quickly. You can just familiarize yourself with the tools instead of like worrying about the fundamentals and the science behind it.
I see. Yeah, for me, I would have to agree with your point. For me, honestly, not everything. When I was applying, I also saw JDs with a long list of tools and skills. And honestly, I had no idea what those are at first. So for me, I had some exposure through the ASEM program, as I've mentioned just now. So I did understand the basic general IC design flow and some of the tools and maybe the kind of thinking needed. But I definitely did not know everything in the job description before getting hired. So I think at least for fresh graduates, companies do not expect you to be an expert immediately.
Yeah.
So what matters more is that you have the fundamentals, you are willing to learn, and you can show that you are resourceful. So the tools can be learned on the job, as what Jasmine has said. But I think at the end of the day, it is still your attitude, that problem-solving mindset, and the ability to pick things up quickly that are very important. So yeah.
Uh, Nigel,
Mhm.
can I take one question from the chat? I think it's a very
Yeah,
interesting question from
yeah,
Alex.
definitely. Yeah,
So
definitely.
Alex is asking, what's the future of Malaysia's semiconductor industry over the next 5 to 10 years? So basically, traditionally speaking, Malaysia has been very post-manufacturing. The factories and the like Intel AMD back then in Penang are mostly doing testing, packaging, and stuff for post-fabrication. But in the value chain of the IC design, there's the fabrication, and the post-fabrication. With the new chip initiative, I forgot the name, new semiconductor strategy, I believe, the name of the initiative. We are trying to move up from the lower value chain to the higher value chain. So we are trying to move on design. So Malaysia is trying to move out towards the more design phase, at least in the next 5 to 10 years, based on the new semiconductor strategy. But that is not to say you should just go to design.
Yeah.
Whenever chips are designed, especially in terms of AI, IoT, NOCs, and stuff like that, you always need fabrication and packaging. So they will always be relevant. They will actually be extra relevant in lieu of the AI needs, data centers, and so on. So if you do not have a electronics or semiconductor engineering degree, don't worry. You can always apply to packaging, fabrication, or go to the upskilling program. There is always a niche for you. Maybe if you're very good at chemistry, you can join the fabrication. Maybe you can work with epitaxy or you can work with the chemical processes. If you have a management sense, you can maybe go to the process engineer. And of course, anytime if you involve in MNCs or very big supply chain, you can even work in supply chain. You can even work like in the accounting and so on. There's so many. Semiconductor is a very broad industry. It's worth trillions of dollars, and there's a lot of whenever you look at a phone, for example, there's a lot of things inside. It's not just Intel, AMD, NVIDIA. Those things, whenever they use packaging, there's companies that you might not even heard of. There's this one company which produces a toilet bowl ceramic. I forgot which company, but basically they help to do the ceramic for the fabrication process. So even from the toilet bowl company, they can even be involved in semiconductor. That's how broad semiconductor supply chain is.
All right. So maybe I'll just go back to the previous question since Agil is back, right? So, I mean, there are many JDs out there, right? I mean, essentially, I was asking, there are many JDs that ask for a long list of skills and tools. So, as fresh graduate, how would you, or at least how much of this did you actually know before getting hired? So, Agil?
Apologies, I think my RAM and flash could not handle the overwhelming chat, so maybe it's time for an upgrade. But yeah, let's go.
Okay.
I think JDs, a lot of job description, information overload is the era that we live in right now. So how do you abstract valuable things? How do you give value in all this noise, right?
Yeah.
So job descriptions, I think one thing that would help is if you know you are going to go into a certain career, right? You assimilate what is the common ground between all of these job descriptions. For example, in embedded software, let's say if they want you to know like bare metal programming, they want you to be proficient in C, C++, or like a certain software. You find all these common denominators in all these job descriptions, and then you cater your resume and gain more experiences in all these common denominators, which would help you land better jobs, which is land better opportunities, I would say, because you're broadening your how to say, you're keeping your options open. Yeah, job descriptions. Wait, let me think. I think that will be my answer to put it shortly. Yeah.
Yeah, I definitely agree with your answer, Agil. Yeah. All right. So the next question was, what is the future of Malaysia's semiconductor industry over the next 5 to 10 years? And how does today's industry differ from the past? And of course, what opportunities exist in the semiconductor industry for graduates who do not have an E&E background? So maybe, Fazlyana, would you like to answer this or take this question?
Wait, I will read the question. Future next, how long is it develop the ASIC?
I mean, my answer to that question would be
Okay.
probably, yeah. I mean, maybe if I can answer first, I think that Malaysia's semiconductor industry has a strong future. So, I mean, in the past, Malaysia was known more for back-end work like assembly, testing, and packaging. But now I think the industry is moving towards high value areas like IC design, embedded systems, and advanced packaging, right? So for graduates without an E&E background, I would say there are still opportunities in software, IT, automation, and project roles. So the key is not necessarily having a semiconductor degree, right? But knowing how your skills fit into the industry and being willing to learn the fundamentals, right? Maybe Agil or Fazlyana, what do you think of it?
I think I can let Fazlyana go first because she was saying something.
Yeah, sorry. Yeah.
Like Jazman said before this, you mentioned the semiconductor is not just about engineering, it's not just about designing anything technical. Yeah, for me in semiconductor, if you don't have an EE background like me, I don't have an EE background, but my project was mainly on the Arduino in IoT lah, I would say. You have more opportunities in semiconductor, I would say, because you can go on the supply chain. You can, like Jasman said, you can go on the supply chain. You can and then on, but mind asking what background are you in now? If you don't have, you mentioned you don't have a EE background, right? But what background are you in now? I think depends on your background lah. Semiconductor or any field, it has it has other related jobs also. In semiconductor, it has potential jobs other than electrical designing or software.
Okay. maybe a final remark from you, Agil. So,
About
we
the
like to add anything else?
semiconductor, is it? Some
Hmm.
semiconductor industry and how is it,
Yeah,
which direction is it going?
yeah, or maybe just any opportunities that exist within the field
Yeah,
itself. Yeah,
okay.
what do you think?
So I would say it's really dependent on the projects that you work on. Like, for example, the project I'm working in, what we're facing is something called like a RAM and flash crisis. What is happening right now is all the companies, they are repurposing their RAMs and flashes to cater more towards AI because the demand is already there. So now it becomes a question, like, for example, my company, if the RAM and flash just keep getting more expensive, how are we going to support our legacy devices or the existing devices which cater for like non-AI purposes, right? So it depends on what position you are in. So in this scenario, in my case, I have to be more resourceful, find an alternative which, let's say the manufacturer is not catering for that specific RAM or flash anymore. So how am I gonna be resourceful and find another that works with the same efficiency? And yeah, this is the reality of things. Everybody is like going towards the demand, so you have to make ends meet somehow. Yeah.
Yeah, so I mean, the key takeaway here is that I think the key is not necessarily having a semiconductor degree, right? It's
Yeah.
not, honestly, it depends, right? But you need to know how your skills fit into the industry and again, be willing to learn the fundamentals. Because at the end of the day, everything still relies on the fundamental and how well you know the fundamentals, right? So I think with that, we have come to the end of today's session, right? So I just want to say thank you to Agil, Jazman, and Fazlyana for sharing your experiences and advice. And just thank you to everyone in the audience for joining us and asking questions. And we really appreciate it. So I really hope that today's session gave you a clearer and more realistic view of what it is like to start a career in engineering, and not IC design and just the wider semiconductor industry. And I will hand it back over to Shaswan.
So thank you, Nigel. Thank you, Jazman. Thank you, Agil and Fazlyana. So it's a great to see all of you doing so well and making an impact in your.
Welcome to the ASEM Academy portal. Click on Explore K Youth to check our flagship tracks, our unique training layout. Click Apply now under the track that fits you. Submit your application today.